Hello everyone and welcome to ITLS Academy Empower the Youth. So today in this lecture we will going to start about mass spectrometry. So it is a broad topic of spectroscopy technique in which we will going to cover its introduction part, we will going to cover its working principle, we will going to understand the instrumentation parts, we will going to understand what are their advantages and disadvantages, we will also cover its application, and at last we will going to cover its important questions that can be asked in interviews, that can be asked in your examination. So let's get started with the topic and let's see the introduction part. So, what is mass spectroscopy? This is a question that every techniques we have till now understand or we have learned about each technique. So today we will going to start with mass spectrometry. So see, mass spectrometry, it is a very powerful analytical technique that is basically used to quantify known materials as well as it is used to identify the unknown compounds that are present in a sample. And this technique is also used where you want to know the chemical properties of different molecules. So this technique basically studies the effect of ionizing energy on molecule. Since nowadays mass spectroscopy is used in many areas, or you can see in many of the industries. For example, it is used in pharmaceutical industries, it is used in clinical industries, it has a huge application in geological industries as well in biotechnology and environmental sciences. So this is a huge or important techniques which is covering a huge area of industries. Okay, so basically as I have told you that this technique is a micro analytical technique which is requiring only a few moles of the samples. Since because of the micro analytical sample technique, so micro means very small, so they require very few nanomoles of the sample. Why they require these nanomoles of the samples? Just to obtain the characteristic information of the particular molecule, of their structure, their weight of analyte. Okay, so this technique is also known as micro analytical technique. So I'm just writing some keywords, you can note it down somewhere. The first keyword is mass spectrometry. I'm just writing it in a short. Is a micro analytical technique. Okay, so why micro analytical technique? Because they are requiring only a few nanomoles of the sample. And why they are requiring these nanomoles of the sample? Just to obtain the characteristic information pertaining to the structure as well as their molecular weight of the analyte present. Okay, now let's see what is written here. So mass spectrometry is an indispensable analytical techniques used analytical tool in chemistry, biochemistry, pharmacy, medicine and many related fields of sciences. Okay, so we have already covered that it has a huge demand in different sectors like pharmaceutical, clinical, geological, biotechnology and environmental. So this mass spectrometry is employed to analyze the combinatorial libraries sequence biomolecules, which helps to explore a single cell or object from the outer space. So because it is used to explore a single cell, it is known as a micro analytical technique. Okay, so this is the whole introduction about this technique. So we will going to move further and we will going to see what is the definition of mass spectrometry. So mass spectrometry, it is an analytical method used for calculating the mass to charge ratio. This is very important. Mass to charge ratio of one or more molecules that are present in the sample. Means this technique is used to calculate the m by z ratio, m for mass and z for charge. Okay, since the name suggests mass spectrometry, so it is used to calculate the mass to charge ratio of the sample, of one sample or more than of one molecule or more than one molecules that are present in sample. So such measurement may also often to be used to determine the precise molecular weight of sample component. So we can also say that it is a powerful technique where you want to know the molecular weight of a sample component that I have discussed in the just previous slide, that this technique is used to analyze the molecular weight of the analyte. Okay, second important characteristic is it is used to identify the unknown compounds that are present in a sample. Clear? Now comes the third point, that mass spectrometry is an analytical method where you want to method to find out the molecular mass of the compound. Indirectly helps to prove the identical isotope. So in short, or in examination, if they can ask you this whole paragraph, like what should be the question here, that mass spectrometry, it is an analytical technique, so which technique is used to identify the isotope? So the technique is the mass spectrometry. Okay, now let's move further and let's see the principal part. So every technique have its own principle, and this principle is very important. Okay, so now before understanding the principle of mass spectrometry, I would like to explain you a history of this mass spectrometry. So student, if we talk about the history of mass spectrometry, okay, history, this is a important part, that who was the scientist behind this mass spectrometry. So the mass spectrometry it was first performed at Cambridge University in 1912. So you can note it down somewhere, that in 1912 this mass spectrometry was first performed where? At Cambridge University. Okay, at Cambridge University. Now comes who was the scientist behind this technique? Who was the person behind this? So in 1912, the scientist's name is J.J. Thomson. Okay, so J.J. Thomson was the scientist who performed this mass spectrometry at the Cambridge University in 1912. How he obtained this or performed this mass spectrometry? So when he obtained the mass spectra of oxygen, nitrogen, and carbon. Okay, so while he was obtaining the mass spectra of oxygen, nitrogen, and carbon, he obtained you can say he first performed the mass spectrometry. So the modern techniques of mass spectro were devised by Arthur Jeffrey Dempster and F.W. Aston. So after that, after few years, the this technique was further devised, or you can say it was further revised by different scientists known as Arthur Jeffrey Dempster and F.W. Aston. Then in 1989, half of the Nobel Prize in Physics was awarded to Hans Delment and Wolfgang Paul for development of the ion trap techniques in 1950s and 1960s. So this is nothing to understand. You just understand here who was the scientist behind this, who was the scientist who further discovered this technique. Okay, redo you can say revised this technique. So this is about the history. Now let's, so the principle of mass spectrometry is based on the Newton's second law of motion and momentum. So basically this mass spectroscopy technique, or its analytical technique, it uses the property of matter. So while using the property of matter, so why it is using the property of matter, the question arises here is just to plot the ions which have different, or you can say varying masses on the mass spectrum. Okay, so from the Newton's second law of motion and momentum, we infer how much mass is relevant, means because of this, on the basis of this Newton's second law of motion, we can understand that how much mass is relevant to the inertia and how much mass is needed for the acceleration of the body. Okay, so this principle is applied to aspect where ions with different masses to charge ratio are deflected by different angles in the electric or magnetic field. So because of this mass spectrometry, it is very important to understand the ions which have different masses to the charge ratio, and they are deflected by different angles that is present in the electric or magnetic field. So simple here that in mass spectrometry, so you can say any organic molecule, they are bombarded with a beam of एनर्जेटिक इलेक्ट्रॉन. बम्बार्डेड मीन्स बहुत तेज़ी से बीम ऑफ एनर्जेटिक इलेक्ट्रॉन उस ऑर्गेनिक मॉलिक्यूल पे पड़ती है. ओके, इन द गैसियस स्टेट, और जो स्टेट ऑफ मैटर इज हियर इज द गैसियस मैटर, एंड एट अ under a pressure that is between 10 to the power minus 7 to 10 to the power 5 mm of Hg, and using a tungsten filament. So molecules are broken up into the cations and many other fragments. Okay, so let me draw a diagram for you to get better understanding of this. Okay, sorry, let me draw a diagram for you. See, this is a molecule. Okay, so if I say that I'm just drawing the diagram, then I will going to explain here once again. Okay, so here the molecular ion, radical, cation. Okay, further here, because of the less space, I am just writing it here, fragment. Okay, what this diagram is all about. So again I am just telling you, in this particular mass spectrometry principle, the organic molecule, they are bombarded with a beam of energetic electron, okay, in a gaseous state, and under the pressure between 10 to the power minus 7 to 10 to the power 5 minus 5 mm of Hg. Which type of element is here is using tungsten. So molecules, they are further broken up into cations and many other fragments. Okay, so which type of fragments? Like different fragments like radicals, neutral molecules, radical cations or cations. So after this, these cations are formed due to the loss of an electron. Okay, usually from n to a pi orbital from a molecule. Okay, so all these ions, they are further accelerated by a electric field and they are sorted according to their mass. So after that, in the electric field, these ions, they get accelerated and according to their mass to charge ratio. So here the output is known as the mass spectrum. You can relate this thing with the help of the definition that we have studied in the slide number 2. Now comes the instrumentation part. So if you see the instrumentation part, then the main 4 parts are there to discuss. First is ionizer, second is accelerator, third is deflector, and the last one is your detector. So what are these 4 parts used for? So if you talk about the first one, that is the ionizer, so what is the principle, or what do you understand by ionizer, or what is the use of this ionizer? So ionizer is a very important part of this mass spectrometry. Why? Because it is involved in the bombarding of the sample is done by an electron. So these electron move between cathode and electron, because electron moves between anode and cathode. So when the sample passes through a electron stream between the cathode and anode, electron which have a very high energy knock electron out of the sample and form the ions. So what are the ionization sources here? So different types of ionization sources are there. For example, MALDI, for example, FAB, for example, EPI. Okay, basically its mechanism is the protonation, or you can say catenization, electron ejection. Why? Because it is just knocking the electron out of the sample and it is forming the ions. So because it is forming an ion, so you can say it is a patternization, protonations, catenization, electron capturing. Now comes the accelerator. So accelerator, in this, the ions, they are placed between the set of charged parallel pallets, or you can say not pallets, plates, and they are attached to one plate and repel from the other plate. The accelerated speed can be controlled by adjusting the charge on the plates. Now comes the deflector. So the magnetic field deflects the ion based on its charge and mass. If an ion is heavy or has 2 or more positive charges, then it least deflected. So this is very important line, student, that the magnetic field, it is used to deflect the ion. So how they are deflecting the ion? Based on their charge and masses. Okay, so if the condition is here, if the ion is heavy, means if the ion is heavy, molecular weight is more, okay, or if an ion has 2 or more positive charges, so then it is least deflected. Okay, when it is least deflected, when the ion is heavy or it has 2 or more positive charges, so it is least deflected. So if an ion is light, is light, or it has only one positive charge, then it is deflected the most. So this is very important. I'm marking this thing important. You can go through it. Now comes the detector. So the ions with the correct charges and mass move to the detector. The ratio of mass to charge is analyzed through the ions with the help of the detector. So this is the whole is thing behind the four main part. Apart from this, it have a inlet, okay, means from where the sample is introduced. Then it has a source, basically it is a gas phase ions. Then it has a analyzer basically used in ion sorting, and it has an ion detector for ion detection, and it has a data system and further data output. Okay, so it has an inlet system where the selection of sample depends upon the sample and the sample matrix. So because if the analyte is sufficiently volatile and thermally stable, the variety of inlets are available. Okay, because since so this is the instrumentation of mass spectrometry. Now we will going to understand further how the working of mass spectrometry take place. Okay, this one is again very important because here we are talking about how it is working. Okay, so the first thing to understand here is how in an ion sources, see in the ion sources, this sample molecules, as I have told you earlier, they are bombarded by electron, and these electron from the heated filaments. So which type of filaments here it is used? The tungsten filaments. Okay, so the volatile liquid sample or and the gases come into the ion sources from the reservoir, and the non-volatile solids and liquids are added directly. So if you are using a sample as a volatile liquid or gases, so they are used into the ion sources from the reservoir. But if you are using a non-volatile solid and liquid, so they can be added directly. सो वोलेटाइल के लिए अलग है, उसको फर्स्टली उसको आयन सोर्स से कलेक्ट करेंगे, आयन सोर्स को फ्रॉम रिजर्वायर से कलेक्ट करेंगे. वेर एज अगर नॉन वोलेटाइल सॉलिड्स और लिक्विड्स आप यूज़ करो तो यू कैन एड इट देम डायरेक्टली. सो हियर द कैटायंस आर पुश्ड अवे बाय द चार्ज रेपेल plate and it moves towards the electrode. So here the cations, they are moving, or they are pushed away from the charge repeller plate. So since they are pushed away from the charge repeller plate, so they move towards the other cathodes, and the ions they are attracted to the plate. Okay, so the plate has a slit. Why? The plate have a slit where the electron passes through a beam. So we have discussed about the slit in our previous lectures also. The main function behind the slit is to where the ion can pass in the form of a beam. So here the perpendicular magnetic field is applied, which deflect the ion beam into an arc. So ion beam is deflected into an arc. So the lighter ions, they are deflected higher than the heavier ones. The reason for this we have discussed in this deflector. Okay, so the ions that are lighter, so they are reflected higher as compared to the ions that are heavier. So by analyzing the strength of the magnetic field, so whenever you want to analyze the strength of the magnetic field, the ion having different masses are detected by the detector. So according to the mass spectrum formed by the charged ions, one can determine the molecule or atom compared with the known molecular masses. Okay, this is how the working take place. Sample is injected. So this is an injection port. Sample molecule are present here. Electron beam is here. Sample vaporizer filaments. Which type of filaments? Tungsten, mostly tungsten. Then they have accelerated ion beams, and here it's a magnet is here. So I have already told you that because the magnetic field are perpendicular, so since the magnetic field is perpendicular, so the straight beam, this you can see now, so this is the straight beam, so they end up in the form of an arc, this line. The perpendicular magnetic field deflect the ion beam into an arc. So as you can see, this ion beam is deflecting into an arc shape like this portion. Are you can you see this portion? So since because it is present in the magnetic field is perpendicular here, so the ions are deflected in the form of an arc is forming. Okay, here the detector is present to detect the signals. Now comes the high resolution mass spectrometry. Okay, now comes the high resolution mass spectrometry. So what is this HRMS? So HRMS means high resolution mass spectrometry. Basically it is used where you want to analyze any complex chemical compound or you want to determine any isotope. So there the high resolution mass spectrometry is used. Okay, so where it is used, where you want to analyze or determine the isotope, where you want to analyze any complex chemical compound, so there this mass spectrometry, high resolution mass spectrometry is used. Okay, simple. Okay, it why? Because it has a very high it has an increased resolution, so you can help in differentiating the isotopes, and you can get the and you can generate the fragments pattern and library matching for the compound verification. So HRMS is not replaced for the low resolution mass spectroscopy. Why? Because it is an advanced technique used to determine the unknown compound and also generate their molecular formula. So it is quite expensive as compared to the low resolution one. Why? Because it involves the determining of unknown compounds, as well as they are generating the molecular formula, and of course it is an advanced technique, so that is the reason it is more expensive as compared to the low resolution mass spectrometry. Now comes the advantages and disadvantages. So if you can see that it works with a small sample size, they are fast, they can helps in analyzing the differentiate isotopes. So here it has a ability where you can handle the sample with the large masses. Okay, the masses of then it has a very good sensitivity, so it can give you an accurate quantitative as well as qualitative measurement also. Okay, so but there are again some disadvantages also. They does not give the direct structural information. This is the drawback. They can they are the apparatus is very difficult to clean. As you can see this apparatus, so this apparatus is very difficult to clean, and they have a tendency to become overly contaminated with the residue from the previous experiments, since the cleaning is very complicated, is sorry, it's very difficult. This is one of the disadvantages. Okay, the requirement of the pure sample, so against the cost, not ideal for the non volatile compounds. So if you want to analyze any non volatile compounds, so they are not ideal. So these are certain disadvantages. Now let's talk about the applications. So earlier, or you can say in the introduction part, we have discussed that it has a huge application in different field, like in environmental analysis, in pharmaceutical analysis, clinical application, forensic analysis. Okay, like if you want to identify protein, and if you want to identify its characterization, so this technique is widely used. If you want to study any non-covalent interaction, against this technique has a huge application. If you want to do any chemical imaging, so this technique is a good method to do the chemical imaging. Then it is also used where you want to identify or quantification of hemoglobin variant. Okay, so it has a huge demands in different sectors. Now it is becoming a very important tool in forensic analysis also, where you want to confirming the drug abuse or identify the explosive or arson investigation, etc. So it has a huge demand in different sector. Now these are certain key application and the field of application with the explanation. So in the elemental and isotopic analysis, physics, radiochemistry, geochemistry. So this is the whole key applications and the field of application. So you can take a screenshot of this table. So it has a huge application in different field. So that brings to the end of the lecture, and basically two things I have used here, MALDI, and I just want everyone to understand what is MALDI application. So I'm just looking forward for your replies in the comment section below, and I would like to see how many people can tell what is MALDI and what is its applications. So again students, if you face any difficulties in any of the slides or in any part of the lecture, you can simply leave your queries in the comment section below. So in the next lecture I'll be answering all the queries. You can follow ITLS Academy on Twitter, Facebook, Instagram, YouTube, LinkedIn. This is our helpline number, that is 7080833450. You can visit our website, that is www.itlsacademy.com. Thank you for watching. Please do like, share and subscribe, and don't forget to press the bell icon to get more updates. So again, thank you, and you can subscribe ITLS Academy. And if you want to get its app, so you can simply go on Google Play Store, where you can download the app of ITLS Academy. So thank you students.